Picture this. You're floating in deep space and ahead of you is a black hole. An absence so perfect it looks like reality has been deleted. No surface, no color. Just a boundary where physics stops making promises. But around that darkness, the universe is on fire. A disk of superheated gas whips around at insane speed. Light bends into arcs. Stars behind it warp into rings. And then you realize the real horror isn't that a black hole eats matter. It eats time. Near a black hole, time doesn't flow evenly. It stops being a shared river. It becomes personal, local, uneven. The closer you get, the more your clock disagrees with the rest of the universe. And here's the crazy part. This isn't science fiction. This is real physics, tested, measured, and already affecting technology we use every day. So today, we're walking to the edge of a black hole, and we're going to watch what it does to time, and why the closer you get, the more you risk leaving your entire life behind. Let's start with the rule that changes everything. Time is not universal. On Earth, we treat time like it's the same for everyone. 1 second for me, 1 second for you, tick, 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 like the universe runs on one master clock. Einstein destroyed that idea. Time is tied to gravity and motion. If you move fast, your time runs slower compared to someone who stays still. If you sit deeper in gravity, your time runs slower compared to someone higher up. Time isn't a shared soundtrack. It's a personal tempo. And this isn't just a cool theory. We literally correct for time differences in real life. GPS satellites experience time differently than clocks on Earth. Without those corrections, your navigation would drift and get worse and worse. So time distortion is not fantasy. It's a feature of reality. Now take that small Earth effect and crank gravity up until it becomes a weapon. That's what a black hole is. A black hole forms when enough mass gets crushed into a small enough region that gravity becomes extreme. So extreme that beyond a certain boundary, nothing can escape. Not a rocket, not a radio signal, not even light. That boundary is called the event horizon. It's not a wall, it's not a surface, it's a point of no return. And near that horizon, gravity drags on time itself. This is gravitational time dilation. The closer you get, the slower your time runs compared to someone far away, not because you feel slow, but because the universe outside your position is moving faster relative to you. And here's where people always get it wrong. You won't feel your own time slowing. Your heart still beats normally. Your thoughts still happen normally. Your seconds still feel like seconds. Time dilation doesn't turn you into slow motion. It makes everyone else fast motion. So let's make it real. You and a friend start identical stopwatches. Your friend stays far away in deep space. You travel toward the black hole, spend time close to it, and come back. To you, it feels like a normal trip. But when you return, your friend's stopwatch shows far more time passed than yours. Your watch is behind. You're younger. You've traveled into the future. Not through a portal, through gravity. That is real time travel. And black holes are the most extreme version we know. Now here's where things get truly unsettling. From far away, if your friend watches you approach the event horizon, they don't see you cross it. They see you slow down, not because you're actually slowing, but because your signals are getting stretched and weakened trying to climb out of the gravitational well. Your light redshifts. Your transmissions arrive slower and slower. Your image fades. From their perspective, you approach the edge and never quite get there, like the universe is buffering. But from your perspective, you cross the horizon in a finite amount of time. No freeze, no pause, no invisible wall. You fall, and you pass the point of no return. The problem is you can't tell anyone you crossed it, because no message from inside the horizon can escape back out. So both views are true at once. Outside observers see you freeze and fade, while you experience crossing normally. Black holes force you to accept something uncomfortable. Reality depends on where you're standing. Now, how close can you get without dying? It depends on the kind of black hole. A small black hole is violent. The tidal forces, the difference in gravity between your head and your feet, can stretch and rip you apart. That's the famous spaghettification. But a supermassive black hole, millions or billions of times the mass of our sun, has a huge event horizon. The gravity gradient at the edge can be much gentler, still lethal if you cross, but you can get closer before your body gets torn apart. So if you ever wanted to use a black hole for time dilation, you'd want a supermassive one, like the black hole at the center of our galaxy. And now imagine the ultimate mission. You don't fall in. You orbit close to the edge and you stay there. Your clock runs slower. The universe runs faster. You come back and you've skipped ahead. This is where Hollywood loves to throw numbers around like 1 hour near a black hole equals 7 years on Earth. And here's the honest truth. The principle is real, but the setup is brutal. To get extreme time dilation, you need to get deep into the gravitational well, likely near a rapidly spinning supermassive black hole, and survive radiation, orbital instability, and the insane energy cost of escaping. Because this is the part nobody says out loud, time dilation has a price. The closer you get to the horizon, the harder it becomes to climb back out. Gravity is literally stealing your ability to return. So yes, black holes can give you a cheap ticket into the future, but they may not sell you a return flight. Now let's talk about why black holes look like the universe is glitching. They bend light so strongly that the sky turns into a warped mirror. Stars behind the black hole can appear as arcs, rings, or duplicated images. In some regions, light can even orbit the black hole. Think about that. A beam of light trying to go straight, forced into a loop because space-time itself is curved. That's why black holes don't just distort time. They distort what you can even trust your eyes to tell you. And this also makes black holes measurable. We've watched stars orbit an invisible massive object at the center of the Milky Way at insane speeds. We've detected gravitational waves, ripples in space-time from black holes colliding, and we've captured images of black holes as shadows. So when we talk about time distortion near black holes, we're not guessing. We're following the math that matches what the universe shows us. Now for the part that hits emotionally. Imagine you have a twin on Earth. You orbit near the horizon for what feels like a week, then you escape and return. To you, it's been days. To Earth, it could be years. You step off the ship and the world is different. Cities changed, technology changed, your friends got older. Maybe they're gone. You didn't lose time, you traded it. That's the real horror of time dilation. It separates you from everyone you love, not by distance, but by time itself. And if you cross the horizon, here's the simplest way to understand it. The event horizon is where out stops being a direction you can reach. Even if you fire engines, even if you do everything right, every possible future path leads deeper inward. Inside the horizon, escaping is as impossible as traveling to yesterday. And depending on the black hole, you might not even feel the crossing. No explosion, no wall, just a silent point where the universe removes your option to return. That's why black holes are terrifying. Not because they're stronger than rocket spikes, but because they rewrite what directions even mean. So what's the clean takeaway? Gravity slows time. Extreme gravity slows it dramatically. Black holes create the most extreme gravity environments we know, which means they create the most extreme time distortion we know. That leads to one unavoidable conclusion. Time travel to the future is physically possible. Not with portals through gravity. Spend time where time runs slower for you and the rest of the universe runs ahead. Return, and you've jumped forward. But it's one way in the sense that you can't bring the past with you. You can only leave it behind. So here's the final question. If you had the chance, would you do it? Would you trade 1 week of your life to watch decades pass on Earth? Would you step into the future knowing the world you return to might not recognize you? Tell me in the comments, yes or no? And what scares you more near a black hole? The gravity, the radiation, or the idea of time leaving you behind? And if you want the next episode, subscribe, because next time we're going even closer to the edge, where time distortion stops being a concept and becomes a point of no return.